Hello, everybody, and thank you for joining us at the Microsoft Power BI UK user group. I'm your host, Leon Gordon, and it's fantastic to be back with you for what we have another insightful session brought to you by a technical expert within our industry, and we're going to learn some more together as a community on Power BI. So our guest with us today is going to be Microsoft MVP, Ryan Wade, and we're going to go through how to get the most out of R and Python integration in Power BI. Now, as always, we want this to be an extremely interactive session, so the Q&A functionality is now open. To everybody joining us, it would be great to know where you're dialing in from. Hopefully we have some international users, and please bear in mind that we try to answer all of the questions that do come through in the Q&A. As I mentioned, we have the highly anticipated session today, and I'll just give you a bit of a background on Ryan before we go into his session I hand over. So, as I'm sure you're all aware, Ryan is an experienced and advanced data analytics professional. His education, technical skills and business acumen enable him to understand things from a technical, analytical and business viewpoint, and he is intuitively presenting complex data using sound analytical visualization methods and has an advanced understanding in R, Python, DAX, SQL, VBA and M, which is extremely beneficial for us today, and I'm looking forward to learning a lot. As I've already mentioned, Ryan is a Microsoft Data Platform MVP, and he's also the author of Advanced Analytics in Power BI with R and Python, to which I will share the link for the book very shortly. So without any further ado, I will hand you over to Ryan.
How you doing? Can you hear me fine?
Yes, fantastic.
All right, perfect. Okay, so yeah, so as Leon said, we're going to go over how to use R and Python and Power BI. Now, this is part 2 of a presentation. The first part, and I will show you some information about that in a later slide, was covering another talk, and that's covering the setup and what have you. And to try to put that all in one presentation will require a super long presentation. So with that being said, we have it in 2 parts, a part A and a part B, or part 2, which you are seeing now. So before we get into the presentation, I would like to tell you a little bit about myself. As just was mentioned, I am an author of a book, Advanced Analytics in Power BI with R and Python. I have a passion about this integration. I think that since the integration started with R, I think back in like 2016, and then later with Python, it hasn't been used to its fullest capability. So with that, I gained some information and some knowledge over the years, and I thought it'd be wise to share it in the form of a book. In addition to that, I'm also a Microsoft MVP, and my day job, I work for a consulting firm called BTS. It's a US-based consulting firm that specializes in the whole Microsoft data stack, data platform. So with that being said, let's talk about the agenda of today's webinar. First, I will give you right now, this is the extent of the recommendations for the setup. This YouTube URL that you see in front of you right now is a link to a video that goes over in depth the setup process when you're integrating R and Python and Power BI. From an R side, it's pretty trivial, but from a Python standpoint, things can get a little funky, for lack of a better word. So in this video, I think it's close to an hour and a half. Majority of it is a lot of back and forth between the presenter and between the host and I, but it's an in-depth presentation that shows you how to set up your environment and how to overcome many of the obstacles that you may have. With one of the things I mentioned in the YouTube video that I have a link to above is my recommended working environment, the one I choose to work in, and that is the Data Science Virtual Machine. The Data Science Virtual Machine is great when you're doing advanced data analytics. Reason why is because it comes built in. It's a virtual machine that comes built up with many of the tools that you use when you're doing data science or advanced data analytics. That includes SQL Server 2019, I think, is the current version that's installed on there now. Maybe soon they'll upgrade it to 2022. And one of the nice things about the setup with SQL Server is that it also has pre-installed SQL Server machine learning services. That's set up correctly. And sometimes when you try to set that up by yourself manually, you may run into issues. And then it has Anaconda, which is the main distribution that people who do data analytics using Python, that's the main Python distribution that they use. And that is a distribution of Python that comes with a lot of tools, the Jupyter Notebook, VS Code, all kinds of tools that you use when you're doing data analytics using Python. And then as you can see, there's a lot of other tools that is built into the data science machine, including Power BI. When you look at some of the Microsoft documentation about leveraging Python and Power BI, some of the issues that they say you run into when you use Anaconda, for some reason, I don't run into those issues when I'm using the data science virtual machine. So with that being said, this is my go-to development environment when I'm doing anything data science. Another reason why I love this particular development environment is that if I mess something up, I can just delete the VM and spin up a new one. That's not the case, or it's not as easy to do if you mess something up on your personal machine. Then after so that's the extent of what we're gonna go over with the development environment. Again, if you want something that's more in depth, the YouTube video and bullet point 1 would be the place for you to go. What we're gonna do next after I get through this short slide deck is we're gonna go over some of the ways you can use R and Python and Power BI. One of those ways is during the ingestion process. So you see in get data, you probably saw that option to use a Python script or an R script. Well, this part of the talk will cover some examples where you can do that. The next session that we will cover is using the R programming language to create custom visualizations. And you're probably looking at it like, Brian, I see R, but I don't see Python. Well, R and Python are very good, and well, not good, I would say great in their own right. And when I think of data visualization and I think of the two programming languages, R is a clear winner when it comes to data viz. And because of that, when I do anything from a custom visualization standpoint in Power BI, I use R. There's a package in R that I will show you in this presentation called ggplot2 that makes creating custom visualizations it's more intuitive and it's much easier to do, and it's more built out. Now, there are some things where Python is better, and I will show you some of those situations when we go over bullet point 3, where we're doing data ingestion into Power BI. So now that you know what our agenda is, let's go to the live demos. Okay, and before I get into the demos, one of the things, the way we're going to do this particular talk is I want you all to ask the questions that you have, and I will address as many questions as I have the time and ability to address. The way I like to do it is, as I go through the examples, if you have a question, shoot those questions over to Leon. And when you do that, I will ask Leon at the end of each example, are there any questions, and he can spit those out to me. So just shoot the questions out to the host, and then at the end of every example, I will go through and try to address some of those questions. So with that being said, let's go over our first example. And again, the slide deck, that's it. Everything else is going to be all live examples. So the first one that we will do is, when you think of Python and R and Power BI, you think of data science, you think of machine learning. So with that being said, that's like one of the biggest benefits that you get when, from Microsoft adding the R programming language and the Python programming language to Power BI. So there is a basic template that I believe you should follow when you're applying machine learning to your data that you're ingesting into Power BI. With that being said, in the example that I'm getting ready to show you now, it's a very simple machine learning example. In this example, I wanted to point out how to implement a model, not go over how to develop a custom model, because how you apply a custom model that is relatively simple versus one that's relatively complex is pretty much the same. So with that being said, in this particular machine learning model, we have this data set And it's a very, anybody who's done anything in Python or R from a data science program perspective, and you probably did some sort of tutorial. This data set that I'm leveraging right now is a data set that you probably came across, and it's the Boston housing data set. And in this data set, what it does is it gives you different attributes about houses that were prices of houses from a certain time period in Boston, Massachusetts. That's a city on the east coast of the United States. Now, this in this particular example that we have here, we are pretending that we came in with a data set where we had these four, what they call in data science, variables, or we just call them columns of data in Power BI, where we have CRM, which stands for crime, the RM stands for number of rooms, tax, of course, stands for tax, and then this L set, I forget exactly what that was. Forgive me for forgetting. But anyway, in this example, you have variables that you want to use to predict the median value of a home. So in order to apply this particular type of prediction to your data that you're ingesting into Power BI, you need to first have your data scientists in Python in this situation develop the given algorithm. Once they develop the algorithm, they will have, let's go over to the folder. They will have let me get in the right location. They will have what is called a model, and a model is an actual object. It's an object that you can save to disk. So once your data scientists develop their data science model that you use for prediction, they can save that model to disk in the form of what they call a pickle file. Now, the importance of that is that when you're doing data science, I saw an attempt to do data science where they did the training and then they scored the data all within the Power BI script. That's not the way to do it. In a true environment, your data scientists will independently develop their model, and then they can pass that model over to you and tell you, these are the data points that we need, or the data points that the model is anticipating in order to do the prediction. And in that, you are responsible for making sure you get that data in your script and supply that data to your model to score. So in this, in the example that I have here, if we go to VS Code, which is a better place to actually see the data or the code, in this situation, you'll see, I zoomed out a little bit too much. You'll see that we have a situation where we first, we load the data that was saved, not the data, but the model that was saved to disk into memory. And then you can use that model to score the data. Now, one of the things I want to point out to you in this particular situation is the code at line 9. One of the things that you can do when you're scoring data in Power BI using Python is that you can do some types of processing, not line, but line 11. I apologize for that, line 11. One of the things that you can do using Python that you can't do in Power Query are certain types of data processing. When you're doing data science in Python, what the model wants you to do is take all your data and bring it to the same scale. And what I mean by that, you may have a situation where you have like room, that's normally like a number between 1, and if you have a super big house, it may be somewhere around 10. But then crime will be on a totally different scale. Taxes will be on a totally different scale. Rooms may be, on the scale of 1 through 10, but your taxes may be from a range of 10,000 to 1 million. So when you have your data on different scales like that, the data that is bigger can have a imbalanced impact on your model. So with Python, and you notice in line 13, it allows you to, line 11, it allows you to easily rescale your data. You can't, to do this in Power Query would be super hard to do. I haven't found a easy way to do that. And you can't do the type of scaling that you can do in R and Python. So you're able to, in line 11, take your data, rescale it so that it will be in a better format. And then you see in 13, you're applying the prediction, and then you build a model, and then you find a prediction, and then in line 15, you're taking the predictions that you created and you append it to the original data set. You do that in line 15 and 16. So after you do all that, you'll see that we go to Power BI, that you go to get data, we go to home, you go to get data, and then you go to more. If we were doing this from scratch, where this is already done, just giving you the steps. And then once you go to more, you go to other. And then once you're in the other section, you'll see this situation here where it says Python script. You click on that, and then you copy and paste that code inside that script editor. And then once you do that, the resulting data set will be exposed to Power BI as a data set that you can bring into the Power BI data model. So that's one of the things, this is basic process you would go through when you score data. Now, if we want to just look at what that looks like from a step standpoint, we go to transform data, you will see that we go to the source and we click on the gear. You'll see that that same script that I had in VS Code is pasted here. Now, one of the biggest things you need to remember when you paste your code into your script editor is that you need to explicitly tell Power BI what working directory you're using. And you see that I'm doing that in this line of code right here. And the reason why that is super important is because the working directory that you had in VS Code is going to be different than the working directory that you will have in Power BI. So you need to tell Power BI the reference of where it needs to look for the data assets that it needs in order to do the scoring and to get the data. So that's super important you do this. If you don't do this, then Python inside of Power BI can get confused and not know where to get the model file and not know where to get the data that's needed for scoring. So with that being said, are there any questions?
Yes, indeed. We do have one question from George M. And he asks, can R do a pickle file as well?
No, in R, and I'll give an example. I'll do this exact same example in R. In R, it's a different type of file, and it's called RDS. And it's the exact same thing with Python, in that you can save it as an object. Just the object type is different in R than it is in Python.
Fantastic. And outside of that, we just have a couple of comments that sometimes the screen is too small. I know you've managed to zoom in on some occasions, but that's just a bit of a commentary from the participants. Okay. So I'll be more cognizant to to zoom in when I need to do a particular code example. So perfect. In this example that we're going to do right now, and this is more relevant to the people in the U.S., but I'm pretty sure you all in the UK have a similar type of situation. And let me first go into transform data so you can see exactly what I'm talking about, and then we will then I will zoom in on the code, so that we won't have the same issue that we had before. So I'll go to this editor and I'll zoom in. Now, in this particular situation, what we're doing is we're using Python to interact with a data API. Now, in the U.S., we have the U.S. Census that occurs every 10 years. And between those 10-year periods, you have a bunch of demographers that get together and they do estimates of what they think the situation is, in between the full-fledged censuses. So with that being said, there are a ton of data that the U.S. make available to their constituents. And I'm pretty sure there's a similar type of utility or tool that's provided to you all in the UK. Now, the amount of data that the census offer people like us, data analysts, is numerous. The U.S. Census offer or collects data on close to
30,000 data points. Yes, 30000. That's a lot of different data points. And not only do they collect them on 30,000 different data points, but they also collect them on different levels of geography. Now, the levels of geography that they use in the United States, they go from the countrywide to the statewide to the county level, and then to the lowest level being what is called a census block group, which is like the most homogeneous geographical level. Getting to that data, the data is free, but getting to the data is hard. And that's where Python outshines R at. You can do both of this type of thing in both languages, but when it comes to working with APIs, data APIs, the Python programming language is more mature in that area, and this is an example of that. And in this example, let's go over to the VS Code, so you know which is a better place to actually look at the code. We'll go over to VS Code real quick. And in this example too, you'll see that we start off with by loading 2 packages. And let me make sure you can see all this by zooming in. And if you if you see a comment where people can't see the code, let me know and I will make sure I zoom so that people can see. But in this scenario, only thing I want to show you is that how easy certain things are to do in Python and R, but probably be super hard to do if you was trying to do it in Power Query. Now we start off with in lines 4, you see that's how they label the variables. In this situation, what we're doing is we're getting population information for the state of Indiana. That's the state I live in. And they're not using nice descriptive names for the variables. They use names like B06001-001E. You know, so you would need to know how to, you know, what those things means. So you'll see that once you know what variables you want to get, then you can use a list of what is known as tuples. Tuples is like an immutable a data structure. You provide a list of tuples, and in that list of tuples, it'll be the different geographies that you want to get this data on. And in this situation, I'm saying I want, the first tuple is saying I want data from the state of Indiana, and that's what 18 is for Indiana. And then I want all counties, and the asterisk is the thing that will let Python know that I want all counties. Now in line 7, all we're doing, that's the function call. That's where we're interacting with the Census API and sending the request to the Census API, and we get the information back in the form of a data set. And then at the line 10, we're just using that to rename the variables from a cryptic name to a more meaningful name. So you see that we're able to get make a very, for lack of a better word, selective request to the Census API, get that stuff, get the data that we want back in a nice data set, and then consume that data set in Power BI. So without running, if I can go through here, zoom out, and then this, you know, just for kicks and giggles, if I were to run this code, you can highlight it and then shift enter, and then this code will run inside Python, and you'll see how quickly it went out to the Census API to get the data. So if we want to just get a high level view of what that data looks like, I can go down here and zoom in a little bit, and you'll see what that data looks like. You'll see that, you know, that my data went out, got the data, and then I was able to get population information for at the county level for all the different age ranges that you see on your screen. So once, you know, after doing that, once I find out that my script is functional, all I need to do is copy and paste that script inside of Power BI in that get data, in the get data, in the Python script session of get data. And when you do that, what you end up getting back, and I don't know what's going on, it's kind of frozen over here. Okay, let's see. Let's go over to Power BI. I have so many examples open, it's hard to be able to get to all of them. Okay, well, it's not letting me get over. Okay, perfect. Yeah, so go over to, it's not, okay, yeah, that's what it was. I had this window open. So you'll see that I can just take that script, paste it into this script editor, and now the resulting data set from this script will be exposed to Power BI as data that we can use inside of Power BI. Now, this can be super powerful. I've worked with some companies that were trying to do some advanced marketing, and they needed demographic information, and trying to acquire that demographic information was super hard for them to do, and or very expensive. If they knew how to program, in Python and use the data API that I just showed you, they would have not only access to over 30,000 variables at all those different levels of geography that I just mentioned, but then they would be able to bring that data into Power BI and analyze that data inside of Power BI. So that is that particular. Any questions about that? We're going to get to some real good data viz stuff later on, but in terms of using a data API, are there any questions about that?
There aren't currently directly regards to the API, but we do have a question from LinkedIn in regards to the use of Visual Studio Code over Visual Studio.
Visual Studio Code. And you probably have some experiences. When you visualize Visual Studio Code, it's super lightweight. That's one thing. The second thing about VS Code is it comes with these extensions that you need that you can use if you want to go deeper into the data science inside of Microsoft ecosystem. There's extensions for Azure Machine Learning Services. There's all kinds of extensions that you can easily add to VS Code that will make doing data science much easier to do. Now, if you were to use this version of Visual Studio, is much more clunkier than VS Code. It's more sluggish, and then you have a lot of tooling inside of Visual Studio that are unnecessary from a data science standpoint.
Perfect. Great answer. Thanks, Ryan.
Thanks. So we can close off that. And this is one of the, let's get to one that I think is pretty cool. And this one is going to be the last example using Python. I'm going to look at my watch to make sure I'm cognizant of time, because I want to make sure to get to some of the other examples I want to do. But in this particular example, one of the things that I love about Python, but R even more, is the advanced capabilities that you have to scrub data. Now, in this particular situation, we have a situation where you have, say, we have this fictitious situation where we have these call logs. And in the call log, this is just an example of a person at a call center. They may take a call from a particular data or customer, and they need to log information about their particular call. Now, one of the things that a lot of people like to do nowadays is, in a real world situation, they would like to take those comments and probably send it to Microsoft Cognitive Services and send it so that they can get sentiment analysis on their particular interactions with their customers. When you're dealing with things like PHI, that can become a touchy situation. A lot of times you may have some type of NDA or some type of agreement where you can't share personal information with the outside vendor, even if it's a vendor like Microsoft, where they don't care about that particular customer's information. They just use the information to, apply their machine learning algorithm to it. So with that being said, there may be times where prior to sending information to a vendor, you need to mask certain type of situations. And that's an example that we have right here. In this situation, we want to say, we're sending this information over to this vendor. We want to mask all phone numbers and social security numbers. You can do that via regular expressions using R or Python. In this example, it's a Python situation. You see that in the unscrubbed version, we have a fictitious phone number of 344 345-432-5555, and it was changed to this other number. And because this number matches a pattern, both numbers matches a pattern, we can use regular expressions to find those patterns and replace it with whatever we want to replace it with. If we just look at another example, we can randomly choose this one, and you'll see it's the same situation. This one, instead of it being a phone number, it was a social security number. And the social security number, you'll see the regular expression found that pattern and then knew to replace it with the mask that you specify. So with that being said, let's go to the code that we use in order to make that happen. So we go over to the code, you'll see that with Python, what we're able to do, and let's kill this terminal so we can start anew. I will run this code and then highlight it. So what we're able to do in this code, and this is something that you can't do if you wanted to, you cannot do this in Power Query. We're able to use regular expressions. Now, without getting real deep into regular expressions, one of the nice things I like about Python is that it allows us to create a custom function very easily. This is very intuitive. You can see our custom function being defined in line 5 to 11. And in that custom function, in line 6, we give it a regular expression that matches the phone number. In line 7, we give it a regular expression that matches a social security number. And then once we define our regular expression, we use the sub function from the array package, where we replace the pattern with a new mask. So once we define that function, you'll see that how easy it is for us to apply that function to our data in line 15. So with that being said, this is look how intuitive this code is. Whenever I write M code never looks as intuitive as Python code to me. Now, it could be just me. I could be only one, but M code, when I look at it, it doesn't make sense. There's a lot of stuff that's going on that is not that intuitive, but that's not the case with R and Python. So whenever I need to write some code that's pretty complex, and especially if it's doing data ingestion, instead of doing some complicated M, I would go with R or Python. So once we get that code functional, you'll see that we're able to go over to Power BI. And when we go over to Power BI, we're able to, there we go. Okay, go to Power BI, you'll notice that just like before, if I go over to transform data, the reason why we're able to have this data set inside of Power BI is that I took that code that you saw over in Python and VS Code, copy it to the script, and as long as your script returns a data frame, which this script does, you'll see this df at the end, it's returning a data frame, and a data frame is just a tabular data set. That tabular data set will be exposed to Power BI, and you'll be able to bring that into the data model like you can any other data set. So at the point of bringing it in, just like over here, you can see the last thing it does is, it guess what the data types are. If you want to do another step, you can, just like you can with any other data step. Now, one thing before I go into some of the R examples, one thing I want to point out is that you have multiple options. You got the option of using Python in data ingestion using a Python script or R script, or you have this option over here where you see transform. In the transform section, you see this R and Python script over here on the right. I recommend not to use those two. I don't know exactly what the mechanics are underneath the hood, but it's not performant. If I'm bringing in data that's using any R or Python code, I'll just do everything in R or Python. And you're not losing anything by doing that. Any type of data transformation you can do in Python, in Power Query, I'm pretty sure you can do it in R and Python. Matter of fact, there are many more data transformations, especially when you get to string manipulations, that you can do in R or Python that you cannot do it in Power Query. So with that being said, that is the extent of some of the Python stuff. And we went over scoring data via custom model, and then we also went over, masking data, and we now we're getting ready to go over to some R stuff. So let me close out this file, because I think the less windows I have open, the more manageable this situation will be. Okay, so let's go over to R. So the question earlier was asking about storing data in R, and you can do that easily in R. Pretty much using the same type of patterns that you are using in Python. So let's go over in this example the same data set that we had before, where we had those 4 different variables: crime, number of rooms, taxes, and LSAT. And we use those variables to predict the median value using a custom model. You can do the exact same thing in R. So if we go over to R, the only thing I want to point out is that if we go over to R and we run this code, let me restart this to make sure I don't have anything in memory that I don't want in memory. Go to session and restart. So in this situation, you'll see the code. The code layout is the pattern I'm using in this situation is pretty similar. I didn't mean to do that. I'm gonna tell you what just happened. In Python, to execute code, you hold Shift Enter. In R, you use Control Enter. When I try to do Shift Enter and R, it will erase everything. So that's what just happened right there. But doing the Control Enter will take everything that's in my script editor, and it will pass that over to my console with the thing that you see on the right. So now that you see that you have the data set that, now you see that we have the data set that has the information of the original 4 variables, and also that appended column that showed, hold on a second. Yeah, that appended column that showed the predictions. So one of the things I want to show you, and I'm going to zoom in and point this out to you, is one of the benefits that you gain using R over Python when you're scoring data. And I'm going to do a quick summary. And what's the model data? What we're looking at, model. Okay, so let me zoom in on this so you can see it. The type of data that you see right here, where we see all of the different statistics or information about the model, you don't easily get in Python. See, R is a programming language written by statisticians for statisticians. So when you need this type of information, it's typically easier to get when you're using R than Python. So all the stuff that you use or that you learn to use to look at or test the effectiveness of a particular model, the R squared, your T values to see if your coefficients are significantly different than 0, all those type of things you can easily get in R, but it's much harder to get to from a Python standpoint. So that's all I wanted to point out to you from this standpoint of scoring data. Everything is the same in R as it is in Power BI, in that you're using a model that your data scientists created and saved to disk, and then they gave that model to you and told you what variables you needed. That part is the same. What's different is some of the things that you get with R that you don't have with Python. So when your data scientist is developing the model, I think they typically would, a lot of instances have more tools on the R side in many instances when you're doing like regression analysis than what you would in some cases with Python. So that's all I wanted to show you from that standpoint on R. And then there's another thing I want to show you on R before we get into the data visualizations. And that is scoring, that's cleaning data. And this is going to be another example of cleaning data using regular expressions. I thought it was. Where's the? Okay. Well, I think I lied to you. Yeah. Okay. Well, let's skip this particular presentation. What this part was, it was a situation. I can just show you the data real quick without. I thought I had a visual built up, and I think I did on another machine, but I'll just show you real quick an example. And just like before, how you can just take a script, and if your script is functional, how you can use that script and get data in the R script edit section of get data. The same way you can do that with any other script, you can with this. But what I wanted to show you in Power BI is this particular example right here. And what I'll do is I will view the data in Python, in RStudio, and hopefully you can get an idea of what R is doing for you. So let me run this real quick. And then after I run it, I will zoom on a particular instance. The situation we have here, and I apologize for not having the other thing set up, was that if you look at this particular, let's look at row, let's say row 11, for instance. In row 11, you have a situation where you got this this tweet data, and say we had this tweet data that we want to send to Microsoft Cognitive Services. Well, in row 11, you see it start off with a retweet to Mr. R. Jolly. That retweet, that information is noise, it's garbage. It's nothing that's really talking to the sentiment of this particular tweet. You would want to remove those. And then if you look at row 9, you have a situation where you have two retweets. You have the retweet to Annie Suss and the retweet to Govback. I don't know if I'm pronouncing that correctly. You see that we were able to use regular expressions to identify that pattern, and then if you go over to the clean session, you'll see that those retweets were removed from the tweet. Now, if we were to send this over to Microsoft Cognitive Services, we're giving them clean data. So that's something that you can easily do in Power BI using R or Python, because you have the ability to use regular expressions, but you don't have that ability when you're using Power Query. That would not be finding a way to remove those type of situations in a dynamic fashion like you can with R using regular expressions is not possible with Power Query. So with that being said, are there any questions?
There is indeed, Ryan. Again, this one comes in from LinkedIn, and it asks about the different types of data sources that can be used with Python and R. I know you've touched on APIs and some. It's well known as CSVs, but are there any other data sources that can be used?
Yes. This one thing you can do this. You can look at any data source that, and this is mainly on the Python side more so than the R. You can think of any data source you can connect to using Power Query, but plus a gazillion more data sets. And the reason I say gazillion more, not quite a gazillion, but many more. In my previous job, I worked with a well-known data scientist in the genomic industry. And he told me how he was using R inside of Python because he was able to connect to some genomic data sources that was, esoteric. I don't know if that's the correct word, but there was, some data sources that you cannot connect to using native Power BI tools, namely Power Query, but there were specific R packages that allowed him to interact with those data sets. So using R and Python will open up your world to many more different types of data sets that you can work with. You can read, if you're talking about Python, well before Power BI made, what's the name of that data set that's used in Databricks? Not Delta, Parquet files. Parquet files was easily read by Python well before it was made as a viable source for Power Query. The same thing, Delta files, all those different types of very specific file types that are available that don't have a connector in Power Query. I'm pretty sure many more of those majority of those will have a way that you can connect to them from Python. And Python will be the more generic tool that I'll use, or programming language I'll use more so than R. R would be more specific for situations where you have, like I mentioned before, where it's some domain specific area, like my previous colleague had, where he was a data scientist working in genomics, and he knew that there were special packages in R that allowed him to work with that type of data. So with that being said, I'm pretty sure it's going to be next to never before Power BI will create a connector like that for Power BI. Well, Microsoft will create a connector like that for Power BI, especially with the fact that they say, well, we gave you an option where you can use R and leverage a package in R to do the same thing.
Excellent. And I guess one last question there before you can continue is in terms of the Python and R scripts. So obviously moving into larger scale implementations where source control becomes quite key. How would you recommend to utilize that for the Python and R scripts?
I recommend, the same way we do Power BI in general, I follow the same set of rules. When I'm doing stuff in the Power BI desktop, like that, type of development I'm doing right now, this is for self-service. This is for self-service. And this is for like proof of concept type of things. When you get into a situation where you did a proof of concept and now you've proven the worth of it, now it's time to productionize that. So you have different options when it's time to productionize the R scripts or the Python scripts that you're using for data ingestion. One of them is, I mentioned earlier, yeah, I did when I was talking about the data science virtual machine and SQL Server 2019, and also in previous versions dating back to 2016, you first start off with R, but then they later added Python as a language that you can have inside of that particular database. Now, as you know, with the data gateway, for the enterprise version of the data gateway, you cannot use R Python scripts, but you can use as a source store procedures inside of a SQL database. So with that, inside of 2019, SQL Server 2019, you have these special store procedures that pretty much encapsulate R code or Python code that can do some of the same things that your script does here. So when you want to productionize, you can use SQL Server Machine Learning Services as an option, or you can also use some other cloud-based tools that Microsoft have. You want to move out to the cloud, you can only use SQL Server Machine Learning Services on-prem, but you can use it in Azure SQL Azure Managed SQL instance. You can use it there, or if you got some big data, you can use it inside of Databricks. That same Python script with a little bit of refactoring. Like for instance, the Pandas package I was basing a lot of my data manipulation on. That same package is, that same type of functionality is available in Databricks. So there you can move the script that you created and with little or minimum refactoring using a more production environment. So like I said, mention SQL Server Machine Learning Services, Databricks, you can use Python inside of Azure Machine Learning Services. There are tools that you use other than a Power BI desktop when you get to the point where you need to productionize it.
Excellent. Thank you very much.
Okay, bet. So now what I'm gonna do is I'm just gonna show you some visualizations. And I'm not gonna really get into the code. I'll probably get into a code example of one, but I just want to get through and show you. And this visualization right here has some sentimental value to me because this is the very first visual that I built, inside of Power BI when the feature became available. And this is around the time when we were in the US going through a presidential election. And at the time, the person who was running for president, many of you know him, Donald Trump, he made a claim about the situation that we had in terms of a trade deficit with other countries. And I said, Ryan, you are a very good data analyst. I'm pretty sure the data is out there once you go and fact check and once you do some sort of analysis to see if the claims that he made, if they're correct or not. And you can see at the country level what the situation looks like. And I was able to do that with this visual. So one of the things with this visual, without giving you an economic education about the economics of the United States government, without doing that, I just want to point out some things about what makes this visual to me great and something that you can easily do with R that you cannot do if you were to try to use native tools inside of Power BI. Now with this visual, you'll see that one thing that we have a dynamic title that we can easily do in Power BI. But one of the things that we can't do is you see this visual it's a visual of box plots that are overlaid with a Boolean plot. Now a box plot, as many of you know, is a very popular visual and statistics that's used to show data distribution, data dispersion. Now, when you overlay it with the violin plot, the violin plot is a plot that shows it's a density chart that will show you like how that, that particular, how the data, how it is dispersed throughout. So by overlaying both of them, not only are you able to get the benefits of a box plot, but you're also able to get the benefits of the distribution that can be relayed when you use the violin plot on top of that. So that's a visual. That piece right there is not available. But one of the things I like to do as a data analyst is when I do analysis or build a data viz for someone, I want to be able to make sure that I'm telling them the story that I want them to know. I don't want them to try to have to look at the particular data viz and then go to other sources to get the answer that they need. I would like to be able to answer it in a very succinct way inside of the data viz. And with R, you can do some of that type of thing. Like for instance, in this particular red cohort, where it represents countries that we have a negative trade balance with, I'm able to give them specifically the countries that fall in that dynamically. This right here, this 92 countries that you see, and that represents a negative 947 billion, that's not static. That's calculated at runtime. And the position of that particular annotation, that is specifically chosen by me. You cannot do that type of annotation easily when you're talking about using native tools inside of Power BI. So I'm able to, for each cohort, tell them not only how many countries are in that cohort, but also what the impact that they have. And this one, there's 5 countries, 2 billion, so on and so forth. This type of visual will be super hard to do inside of Power BI. And one of the things I like about it is that it, just like with any other visual, it's interactive. So you lose one thing, and but it's still very functional. And then let me go more in depth with what I mean by that. When you apply filters to your report page, those filters will propagate to your R visual, but you cannot have any filters inside of your R visual that will propagate to other outside visuals or filters. So that's one functionality that you lose, and to me that's not a big thing. But you see, we go back to 2014, you'll see how we're able to have those annotations on the chart that would be super impossible to do if we were using another tool or one of the pre-built functions inside of Power BI. And then this is another one. This right here is a forecast. The demand forecasting is going to get pretty big, especially with all the supply chain disruptions that we're experiencing on a global basis. It's going to be important that not only will we, as a global economy, need to get better at forecasting our supply chain, but in addition to that, we're going to need to be able to, when I say we, I'm talking about us technical people that's on this call, we will need to be able to effectively communicate those forecasts with non-technical people. And when you're dealing with forecasts, there's a lot of forecast, visuals that I've seen, and they will only show what you have on the top. You see up here in the top, that forecast, but that is only telling half of the story. There are components of your forecast. You have the seasonality, a seasonality component, and then you have a trend component. And the data that I have here, I use a package developed by Facebook, and it's available in both R and Python called Profit. In the Profit package, what it does is it will generate these forecasts for you. Now, it will generate the data, but these visuals that you would need to, if you were doing some type of demand forecasting, where you were forecasting many different items at once, using the built-in visuals inside the Profit package would not be an option for you. But you can use ggplot2, a package inside R, to create this visual for you. Now, as I said earlier, with With forecast, it has the seasonality component and it also have a trend component. With this one, you'll see from the profit package, we was able to get a weekly the weekly seasonality. So this particular product, it showed that sales on Monday were low and they progressively rose throughout the week. So this will tell you a person like they were trying to do staffing on a weekly basis. They know that staffing on Mondays, well, we could be light on Mondays, but we need to be real high on staffing, towards the end of the week. And then it shows you yearly seasonality. You'll see that in this particular product that the demand tends to be greater in the summer months than in the winter months. And then it shows you what the trend looks like over time. Like over time, you have a a seasonal component. Not only do you have that, but over time, things are going in a upward trend, which is a good thing. So this is important to be able to visualize all three components. One of the things I want to point out before I go to the next chart is that the nice thing about this, you see that in this particular visual, I was able to have the forecast visual up top be bigger than the other ones. And I was able to do that. If I go into the code here, the demand forecasting, you see that in the code, and this would be the only code I want to show you right now. Scroll down. Yeah, it's right here. So I'm zooming into there. Okay, I think I need to go down a little bit more. Okay. Okay, let me try one more time. I'm sorry, I need to learn how to zoom better. This is the code I want to get right here where it says REL_height. You'll see that this is the data structure called a character vector, but I'm able to tell it what size of each image I want it to be. So I'm saying that the sum of those fractions need to sum up to 1, but I'm able to say I want my first visual to be twice as big as the other 3 subsequent visuals. That type of customization, even though with I forget what they call it in Power BI now. I want to say multiples. That concept of multiples, that's been around forever in Power BI. In Power BI, they call them facet charts. Now, I'm gonna be real quick with these last ones. Is gonna be a hard break at 2 o'clock? Me at the top of the hour, Leon?
No, it's fine. It's fine. No problem at all.
Okay, perfect. So I'll probably go 5 minutes over. If I do, forgive me. And I can be available for questions after that. One of the things that I love about R, when it comes to ggplot, is how descriptive you can be with your data visuals. The package I'm speaking of, ggplot2. GG and ggplot2 stands for the grammar of graphics. And we don't have time. I covered this in the first chapter of my book in detail, but this will give you on a high level, the elevator pitch. GG stands for grammar of graphics. And that pretty much says that you're able to intuitively write code to build out a visualization. And you start off with a blank canvas, and then you just build layers on top of that canvas until you may start off with one layer, and then you start off with additional layer until you come up with the visual that you ultimately want to build. And with that, you can become very, very creative in the types of visuals that you build. With this particular data set or visual that we're looking at now, it's a visual where we're drawing a map. It's a heat map. And you're probably saying, Ryan, okay, what's the big deal? To me, what I'm able to do here, I haven't been able to replicate using other mapping tools. Because typically with a mapping tool is that you got to hone in on a certain area, and that particular mapping tool, whether it's ArcGIS or whatever mapping tool that I have used, and if you all have one that's different in this, forgive me, but the ones I've used, they will show you the geography that you're interested in, plus the surrounding geographies that you're not interested in. With ggplot, you can draw out a visual that will only show you the particular geography that you want or that you're interested in. And so in this situation, I know that the sister city to you all is New York City. And you see this is a visual of New York City, and at the lower right hand corner of the map, that's what New York is, but this is a map of the whole state of New York. And it shows you, based off of color coding, the areas of the state that has the highest population. So now I'm looking at New York. Say I want to look at California. I can easily do that. And in my visual, instead of having a geography selected that I'm interested in, plus a bunch of surrounding states, whether it be Nevada, Arizona, instead of having all that in my visual, I'm able to draw out only what I want to see. And that is that type of customization from a mapping standpoint is stuff that I can easily do in R using ggplot, that if I was to use something that was custom, it would be harder to do. To show you another one, this right here. This is an example of a quad chart. And now us being in the Microsoft ecosystem, or the Microsoft ecosystem, Microsoft community, we got so used to the quad chart because ever since Microsoft started being in the upper quadrant of everything when it comes to data analytics and the data platform, every year we see that Gartner report. And we're a lot of times are the ones that's evangelizing that particular report because it shows you how good that the Microsoft is doing relative to other vendors. But one of the things about that, I seen this chart replicated in Power BI. And when I seen it replicated in Power BI using native tools, a lot of things was hacked and it was kind of clunky. But when you're doing it inside of Power BI, inside of R using ggplot, it's really the visual. It's not like you're adding, shade to the area, artificially adding shade using different objects on the screen, or you're pasting in a label. All this stuff that you see on here is done by code. So one of the things that this I want to point out about this particular visual is that with this visual, you got different elements that you don't have available in traditional tools or traditional Power BI visuals. One, let's start off with the title of the chart. We saw LA Lakers player comparisons. So that's the main title. Okay, yeah, you can do that. Dynamic titles has been a part of Power BI for some years now. But what Power BI still don't have is a subtitle. So you see right here, we got the subtitle, and that can be dynamic as well, just like with Power BI. Okay, so that's a good thing. The second thing is a feature that's not available in Power BI, but it's available in R, is the ability to add a caption. Now that's super important when you're doing analysis, like I did before with the where I was like comparing the United States to other countries from a trade deficit standpoint, or in this situation when I'm comparing basketball players in the 2008-2009 basketball season for the LA Lakers. I need to tell people, they say, okay, Ryan, I see what you're reporting. What's your source? Well, you can do that with a caption. That feature is not available. You can hack it, but it's not part of the visual in Power BI. And then some other things is you see these labels here. Those are defined by me. This part of the visual. I'm especially telling Power BI or R where I want these labels to be. High score in this session, where they're a high score but low rebounder. This session right here is they're both a high score and a high rebounder. That's why Kobe Bryant and this guy Paul Gasol, I guess both of them are beasts. And then over here, where pretty much everybody is at, they're relatively low in both scoring and rebounding. And then over here is the high rebounder is a person, Lamar Odom, who was a high rebounder but was a low scorer. So here you see that we have this shade in the second quadrant and third quadrant. That's not easily done inside of Power BI using native functionality. But the big thing is, like, some of the subtle things is, you notice in the Gartner chart how they had this arrow, that point upwards for, like, to tell the end reader that the higher up you go, the better. That's the better direction. The same thing with the rebounding. This type of adding this type of functionality with code instead of hacking it is not possible with Power BI, with native tools in Power BI. But this is all done by code. That arrow was created using the R expression language. So stuff like, so the thing with R, a lot of times when you're trying to build a visual that's unique to you, that is unique to your given situation, is chances are you can the tools that you're given and ggplot will allow you to build that out much easier, much quicker than it would if you had to, use some other functionality. And one thing I want to point out before I go, just from a high level, a concept that that you have with ggplot that you don't have with other with native functionality inside of Power BI. Many of you in the data viz community are very familiar with Stephen Tufte. And I got one more visual to show you, and then we can just go to questions. And then we're also familiar with Edward Tufte and Stephen Few. And those two are the data viz experts. I know, like early on when I got into data viz, anything they said, you had to treat like anything the Italians say. There's been time when I was learning DAX, and in learning DAX, I will think something is a certain way, and then I hear Marco Russo or Alberto Ferrero say something differently. I don't argue against what they say. They study that stuff much more than me. So I say, okay, what I thought was incorrect, I'm going with the Italians on this when it comes to DAX. Well, with data viz, I kind of think of the same thing when it comes to Edward Tufte and Stephen Few. Well, with via the ggplot package, they have this concept called themes. And at the end of your visual, you can just add a theme for somebody like Edward Tufte or Stephen Few, and it will repaint your visual using best principles that those two guys recommends. So like one of the things is, they're big on white space, so it will take out unnecessary color in your chart. So stuff like that, it is done with one line of code. You can go from an ugly chart to a production ready chart by just adding a theme. In addition to themes from those two guys, if you're doing some economic type stuff, there's a theme for the economist where it will paint your visual using principles that the economist publication use. Something super powerful, super powerful. The last visual I want to show is this particular visual right here. And it probably really don't mean anything to you, but this is a visual I borrowed from a guy in the art community that's like the Italians, and like, when it comes to DAX, like what's his name? The is it been gone when it comes to T-SQL, or like it is with the data viz that I just told you about. And that's a guy named Hadley Wookham. Hadley Wookham is by far, I think the most prolific developer of R packages, and he's behind the tidyverse. And if you decide to go to R, I can point you into some resources in that direction. But anyway, this visual was borrowed from his book, and I adopted it for Power BI. But one of the things I want to point out in this particular visual is that if you doing something like we're doing right here, where we're showing economic data, but we want to overlay it with information about, okay, from a political standpoint, which party was in power during that time, so that you can, probably see, is there a trend if you're in the United States when the Republicans are in office or when the Democrats are in office, so you want to see that. And in this particular visual, what we're doing is we're overlaying, we start off with the reign of each political party, and then, with the red representing the Republicans and the blue representing the Democrat, we overlay that with a line chart so that we can easily see, are there any trends visually that stands out when the Republicans are in office or when the Democrats are in office. And one of the things about this is that now that we can add into the benefits of using Power BI, so I can dynamically change what I'm showing right here. And now instead of looking at GDP as a percent change, I'm gonna look at actual GDP, and boom, I'm easily able to update the visual. If I want to say, okay, instead of looking at the overall political makeup of the United States, I'm gonna look at who is in president, change it to that, and you'll see that it will change and show you the shade based off of the government entity that you selected. So with that, that's all that I have to show you. Are there any questions?
Fantastic, Ryan. First and foremost, let me thank you for going through some absolutely amazing information in such a short space of time there for us. We do have a question coming in again from LinkedIn, and they ask about Power BI licensing. Is everything that you've gone through with us today available directly in Power BI? Did any premium per user, premium?
Everything that I went over today is direct, not, you know, I won't say it's directly available in Power BI, but I will say it's freely available. So in the first video that I went over, and that it was a couple weeks ago, it talked about the setup that you need to do. So in order to be able to leverage these capabilities inside of Power BI, you would need to install a distribution of Python on your machine, and you also need to install R on your machine if you choose to use R. And then there's some basic configuration that you need to go through. Once you do that, you have everything you need. Now, all those tools, there's free, but there are there is a setup process you need to go to.
Okay, fantastic. Thank you very much for confirming that for us. And sorry, we did have one more question that's coming in. I'm just trying to get that back up for us now. Just bear with me. Okay, and this is what's the best way to get started in terms of Python and R? So obviously some of the examples that you've shown us there are intermediate and advanced. For somebody who's new to Python and R, what's the best place to get started?
Okay, what I'm gonna do is I'm in the process, and I'm 80% done with building out the GitHub repo for both this session and the one that was previous. But off the cuff of my head, there's a book written by Wes McKinley from a Python standpoint called Python for Data Analysis. Super good book. I recommend that to get started with Python. This thing, having Wes McKinley, I put him into the same category that I place some of those other people in. Super smart, young person. He started off his career in the quant industry, and he is the original author of Pandas. So you'll start seeing some of the unique things you can do with Pandas, and you'll say, "Wow, Pandas is." You may end up falling in love with Pandas, and you may say, "Man, I wish Power Query can do some of these things." I'm thinking that's what will happen. But that book is a great start from that standpoint. You got to pay for that book. But from the R standpoint, I think a book called R for Data Science. Do you know how to spell R, Leon?
You put me on the spot now, Ryan.
No, it's R for data science. I don't know if Leon. I don't know if he's smart enough to spell R, but R for Data Science is a book written by that guy Hadley Wickham. It's free. It's free. All you need to do is Google R for Data Science, and if you do that, Leon, you probably can put it in the chat. It's free in PDF format, and that is by far the best introduction to the R programming language from a data analyst standpoint. And one thing I want to point out, if R and Python are both great languages, and recently Python has become like the super popular programming language. Everybody wants to code in Python now, but that doesn't take away the great benefits of R. It's certainly, one thing is that people that's in data science, they may start off with Python, but they eventually learn R because they see some of the great things about R. The same things that people who start off with R. I have my mentee. She's doing her PhD at Rice University right now. She started off with R, but she's doing a lot of Python stuff as well. So you want to become a polyglot if you get into the data science community. But as I told you earlier, Python is better in certain things, and R is better in certain things. If you had a gun to my head and you say, Ryan, you need to pick one language that you use inside of Power BI, it would be R. Ryan, why you say that? R is a domain-specific programming language. It's a language written by statisticians for statisticians. The things that statisticians have been doing in R that we think is novel in Power BI, they've been doing it for years. Data visualization, they've been doing that since 1993 in R. I think it was 1993 when it was invented. When you talk about data cleansing, they've been doing that forever in that programming language. We think that we're doing something brand new when we get Power Query and we do these data transformations and data cleansing. No, they've been doing that forever in that programming language. And so with all that history, they got a mature tool set that is that lends itself well to Power BI. And one of the things you can do, if you even Google, if you went to the Microsoft documents and you Google the available packages in the Power BI service for Python, I think you get like 8 of them. And that's only coming to play when you're doing data viz. But when you look at the available packages, when it comes to R, it's like 932. So this is what I say when it comes to the R and Python thing. If you're a person that's going to be a data analyst and you see yourself being a BI developer, I recommend you start with R. Now, if you start doing some data engineering type stuff, or even if you're doing something in Azure Machine Learning Services, Leon will tell you, like in Azure Machine Learning Services, Python is way more built out than R. So yeah, you would need to do Python in that area. But for Power BI, and I'm willing to, I would do an international debate free of charge, and we can donate the money to whatever charity you want. But I would debate R over Python for Power BI if you had to choose one.
Fantastic. And I've just had to Google how to find out how to spell it as well. I was getting my Pirates of the Caribbean on and spelling it as a pirate does. But no, wholeheartedly understood. So for everybody that's participating and listening to us today, then please do take on the advice of Ryan and do go and look into R and Python and how you can integrate them with Power BI, but also how you can use them and utilize them to become a better business analyst and obviously explore further into data science.
Yeah. So were you able to find the free book R for Data Science?
I have indeed. So both of the books are currently available in the chat, and when this goes live onto YouTube as well, I'll make sure that they're in the comments section as well.
Perfect. Any more questions you have? And then, like, if you have a question, you can't think of it now, probably the most accessible way to reach out to me will be on LinkedIn. You know, I'm more active on LinkedIn than any other social media. That'd be one way. And then one of the things I'm going to do, and I'll work with Leon to share it on the YouTube post, and is again, I'm putting together a GitHub repo that give you all the resources and probably go into depth in some of the topics I didn't. That I touched on very briefly that you can, look at. So you'll be able to download that repo in your own environment and go through all the examples that I gave you today.
Fantastic. Looking forward to it. Ryan, like I say, thank you very much again for joining us. It's been a highly anticipated session, and the amount of information that you've given to us is absolutely phenomenal. So we can only thank you very much for that and for your time as well.
Thank you, and thanks for the patience.
No problem at all. And thank you to everybody that's been here with us, whether you're new to the Microsoft Power BI UK user group or whether you're here joining us again. As always, I've been your host, Leon Gordon, and our sponsors has been Onyx Data, and we look forward to seeing you again soon. You could have been anywhere in the world, but you've been here with us at the Microsoft Power BI UK user group with myself and Ryan Wade as well. So thank you very much and stay safe.